Hello everyone, in this session I'll be running a simple code snippet in order to explain the working of the instruction CLZ. What is this CLZ? CLZ refers to count leading zeros. As we can guess from the name, this particular instruction is used to count the number of consecutive 0 bits starting from the 31st bit, that is nothing but your MSB, downwards until the very first one is found. Okay, that is, for example, if I consider this particular case, I'm loading a value 0x4 and all zeros into register R0 using pseudo instruction LDR. So what will happen if I use CLZ R1 comma R0? This value in binary is zeros here, then you have 0 1 and all zeros, correct? Now if you check total number of zeros before the very first one, how many zeros you will find? Total 5 zeros are there. Okay, so this is the value which will be stored in the register R1 when CLZ instruction is executed. Let me consider one more example. Here I have taken R0 value as CDEF, whose binary representation is shown here. So here if I check total number of zeros before the first one, how many zeros are there? 16. That in hexadecimal is nothing but 10. Okay, so when this particular CLZ instruction is executed, the value 10 is loaded into register R1. Okay, so let's see all that happening. One thing you should know about this CLZ instruction is it is available in ARM version 5 and above. Okay, it is not available in our LPC2148, because of which I have changed my target from LPC2148 to LPC2919 in order to run this particular code. Very first thing we will do is we'll check if there are any errors. There are no errors. We'll go ahead with debugging. So I'm loading the value 4 all zeros into register R0, and when I count the total number of zeros before the very first one is detected, that is when I use the CLZ instruction, the answer stored is 5, okay, in the register R1. And next, when I consider the next value here, and when I execute CLZ instruction, as we expect, the value 10 is stored in register R1. And you will see the usage of CLZ instruction in DSP, that is digital signal processing, in order to normalize signals in case of bitwise compression, bit manipulation, etc.